Hello and welcome back. This is the Oneway Drill Wizard. I've borrowed this from one of the guys at the Woodturners Club. You basically mount a drill in this hole here. This fits into the banjo. You lock it down nice and tight, and then you use this lever to drill holes into your wood turnings. Now there's some bars in here, and it looks like there's just plastic sleeves that go through here. But in today's video, we're going to try and make one of these Drill Wizard tools. Now I've got this old Black & Decker drill, and you can see when I put it in here and push on the clamp, it still wobbles around, it's not tight. And that's because the collar here, or the diameter, is too small, and it's too narrow for this bracket as well. So when I make this thing, I need to consider the bracket and the collar on here. And the reason why is this drill has a very good chuck. There's no movement or sideways movement at all. So I'm going to be using this drill in the jig. The guides here are 1/2 inch in diameter, and I'm going to build it out of this linear guide. Now if you saw my last video, I showed this linear guide. I was going to use it for my motor mount. However, I have more than one of these, so I'll be able to use this for this job here as well. This one here is 16mm in diameter. I should be able to get it in there. Maybe I need to make it a little bit bigger, but we'll sort of work on that once we get round there. I've gone and got some of the materials for the jig, and I was going to write some diagrams up here on the bit of paper. But from what I see on the device itself, there's 4 main pieces. So there's this piece here, the slide, and the metal bracket that goes around the corner. I have the linear rails for that, and this piece of 100 by 100 angle to use for that metal bracket. The next piece is the housing itself, and I've got this 6mm plate, and there will be some sides put on it and some ends, so that'll be fabricated. There's the shaft that goes down here, so that's the piece that I'm going to use for that. And the last bit is the bracket that holds the drill. Now I did notice when I started to move this that there are screws in here, and that bracket can be removed. So we could make different brackets for different types of drills, and they can be fitted on there quite easily. Now the device naturally goes in and out when you're drilling holes, and you can rotate it in the banjo as well. But what it doesn't do, it doesn't tilt up and down like that. And I think that's a feature that I want to add. I made this threading jig a couple of years ago, and I did add a feature like that on this one where it can tilt backwards and forwards. It's got the same shaft for the banjo, but it has a little hinge in here as well, and that allows it to move back and forward. I have some ideas where that would be quite useful, so I'm going to add that as a feature. The first part is the angle bracket. This is 1/4 inch thick steel, 100mm by 100mm. I'm using a magnet here to make it perpendicular to the table, and then I know that this piece here will be nice and square with it. I've got a measure to have clearance in here, and then once that's done I can clamp it all together so that we can connect these 2 pieces together. Some good things about these linear guides is there's a couple of holes here already. So I've clamped this to the angle plate, and I'm drilling through the holes and right through the angle plate so that we can bolt these things together. I should have done it in the last process, but I put some paper towel in where the bearings are, and I tack this out to M6. I open up the holes here to 6mm for a 6mm bolt, and because I'm using countersunk bolts, I need to countersink these holes. Once that's complete, these 2 pieces are bolted together. Now I'm measuring up the distance between the bars, and also I need to work out the stroke, and that will allow me to work out how much I need to chop off these bars. I chop the bars off in the vise with the grinder and true the ends up in the lathe. A hole is drilled at the cut off end, and that is tapped out to take an M6 bolt. This is the largest sort of accurate measuring tool I have. I did get this at a bargain, but very handy for this because I can make sure that these linear guides are exactly the same length. I have the top part sitting on a spacer. That gives me clearance between the bottom piece and the top part, and now I need to work out how high these holes are for our end brackets. I cut 2 strips of metal for the end brackets. They'll go on there like that. holes will be drilled through so they can be bolted on. Now these pieces were cut a little bit wider with the grinder, so I'm going to clamp them together because I need to make them the same width, and I also need to drill the holes in the same place. The best thing to do for that is to tack weld them together and treat them as one piece. Then they're put in the milling machine and then milled down to the correct width. I drill the 2 holes so they can be mounted to the linear rods. Hang on, I drilled 3 holes because I stupidly drilled the other hole in the wrong place. They were supposed to be 48mm apart, not 58mm apart. But don't worry, we'll treat the other hole as an air vent. All the work is done on this part, so now we grind off those welds. And theoretically, you should be able to bang this on the bench and it flies apart. But I think I had too much penetration in those welds. This is not a machinist square. I've actually used a scraper and separated these bits. I'm going to clean these up and then we'll come back. I've bolted the end plates onto those linear rails, and this works fantastically, if that is such a word. The next step is to make the rest of the box, and I have this plate here, so that will go on there. There'll be a bit at the top and there'll be a bit at the bottom, and these end plates will be welded in as well, but I need to cut the end of it off at the right width. It's quick work with the angle grinder to cut that piece off. And while I'm at it, I'm cutting off 2 strips, one for the top and one for the bottom of the box part. Again, the strips are cut a little bit wider, and I put them in the mill and I true them up to the right width. You can't see much here because there's a lot of protection in place, but I'm putting a couple of tacks in there. I have everything all bolted down and fixed, and then the next part is to weld this top part in here. So I'm just making sure it's square. Put the protection back in place and a couple of tacks in there. I welded up everything off camera and cleaned it all up on the grinder. Also rounded off these edges, make it look quite nice. So that's the box part finished. So that goes there, and technically this should go in, but man, I made these rods a nice neat fit, and you have to be square horizontally and vertically to get this in. Eventually I got it in, and the screws go in, 2 at each end, and then that's pretty much done. There it is in the vise. It travels nicely like that, very smooth, and there's no movement up and down or sideways or anything like that. It is solid as. I put some marks at the top here, and that indicates the stroke, so it's 5mm more than the original tool. Here's a view from the other side. Works very nicely. The clamp for the drill will go over here somewhere, and there will be a handle on the other side. There will be a bracket that goes on the top here, and the handle interacts with that as well. So the next job is to make the handle. Now it's a pretty simple mechanism. It's just got a pivot point here, and up halfway there is a slot cut in here, so that when you actually move the handle, the bolt will slide in that slot. Now the handle on this Drill Wizard is quite sloppy here, so I think we could probably do something a bit better than that. I've got this 20mm round stock from someone from the Woodturners Club, so thank you, Tennis. And I'm sure that I can carve a handle out of this piece of round bar. As usual, cut a piece off to the right length. I've got it in the big lathe here, and I'm just taking off all that rust, so it's going down about 1/3 of a millimetre. Now I have the bar in the mill, and I'm milling a flat on this side, and I'm going down 6mm. I have the bar in a square collet block, which is good because I can just flip it over and mill down the 6mm on this side as well. That pivot hole is drilled out for 8mm, and I also mill a slot in here which is 8mm wide as well. This is a radius jig that I built for my belt grinder. This is a useful tool because you can just round off any stock where you have a bolt hole through there, and it works really well. Now I have the bar in my small lathe, and this is another homemade tool, which is a scissor knurling tool. and I've just got this on a very low speed and feed with a lot of oil on it, and that runs through quite nicely. The handle's almost finished. The knurling came out really nice. I'm not sure what to do at the end, whether to round it round or put a cap on there, but we'll work on that later. Anyway, the handle will get bolted to this part, and there will be a bracket on the top here which will go and interact with the handle there. I'm now working on the bracket for the top, and it's a simple part, a piece of angle iron, has 3 holes drilled in it. These are drilled while I have it still in one big long piece, and then I cut that part off with the grinder. Now I'll do a little bit of shaping on the belt grinder as well to make it look a lot better than just a piece of angle iron. The handle needs to be mounted to the device, and this will be the bolt hole for the pivot, and that is drilled off camera and then tapped out to M6. I need to make 2 shoulder bolts for the handle. So I'm using some M8 bolts here, and they're getting turned down to 6mm so that we can run a 6mm thread. Here's another homemade device for cutting threads on the lathe. Once the threads are all done, the extra bit is then cut off. Those are the 2 shoulder bolts complete. I've bolted the shoulder bolt in for the pivot. Now I need to work out the center of this piece so that I can drill the 2 holes in there. Those holes are drilled on the drill press, and I tap them out off camera to M6. I now have the handle assembly all complete, and the shoulder bolts are here and here, and this works absolutely like a dream. Very smooth indeed. I'm happy with that. The next part will be to work on the bottom here. There's a bracket that needs to go on here, and it will connect to the post that goes into the banjo on the lathe. I've drawn up a little plan here for the post, and I'm going to use this piece of 1.5 inch round stock here to make the post. Now I've got 35mm of play here. If I make that any higher, then I might not be able to get the drill bit center to the center of the lathe axis. So that's kind of important. This is the second part, which I'll make later, and that goes on to that angle plate, and it will fit in this groove here via a bolt that tightens it down. By cutting off a piece of bar to the right length that I need. I've got it in the lathe, and I'm taking off the rust. I'm actually taking this down about 3mm, so that cleans up quite nicely. Then I machined this part down further, so this is going to be 1 inch in diameter to fit into the banjo on the lathe. The machining on the lathe is all done, so that is pretty good. Now the next step is to make these features in here. There's a groove down here, there's also a bolt hole that goes through here, and there's some flats on each side here for the bolt and nut. I'm going to put the part into the square collet block so that I can do this machining. Now I know some of my wood turning friends will be probably watching this. So a collet block is basically an indexing tool. And what you can do is put your work into the collet block. You can machine, for example, the top, turn it around 180 degrees and machine the bottom. And in our case, that will be handy for these flats. And of course the bolt hole, and the slot is 90 degrees to that bolt hole. Now collet blocks don't only come in square shapes, they come in hexagon shapes as well, like this one here. So this will be useful if you wanted to make a bolt and put a hex on the head of the bolt. So you just rotate it round one bit at a time and mill a flat onto your piece of stock. So now I have the part in the collet block and the vise, and I'm drilling a 7.5mm hole here. Then I ream that out to 8mm. So this is going to be the hinge bolt that goes through here. To the left of the hinge bolt is a smaller hole that we need to drill through here, and that will be for the locking pin. Now I need to tap that locking pin hole out, but my tap isn't long enough, so I need to mill a flat on the top here. I do apologise, my camera was not in the best place for this, but pretty much standard 2mm flat gets milled on the top. Then we're ready to go with our tapping, and if you're wondering how I got this all lined up again, Well, before I milled, I set the DRO to 0, and all I have to do is put it back to 0, and then I'm bang in the right place again. That locking pin hole is tapped out to M6. And what do you know, here's another shop made tool, tap handle. And I finished this off by hand. It's a lot easier than doing it in the mill. I've flipped the collet block over upside down now, so I'm milling that 2mm flat on the other side. Now the collet block is set vertical in the vise, and I'm milling the slot down the center. And I'm milling it this way with the y-axis because there's no chance the collet block will tip over. So that's the part almost finished. I still have it in the collet block here because I might need to round over these corners here, and I want to be able to do that nice and evenly, and that's going to give clearance for the angle bracket to pivot. I start working on the other part of the hinge, which is the small piece. This is 16mm steel plate, and we chop a piece off. I square the steel plate up in the milling machine, and then I mill down the surface to the right diameter. I test on the part, it's just a fraction tight, so it just needs another couple of thou milled off. I'll do that off camera. Then this fits in quite nicely. It is a little bit tight in the corners here, so I tack that with a file off camera. This is the hole for the hinge bolt. I drill it out to 7.5mm and then ream it out to 8mm. This part needs to be shaped, so I've drawn on the steel and I use the angle grinder to make those cuts. Those cuts weren't too elegant, but I tidied them up on the belt grinder, and this fits in very nicely. Now I'm drilling the mounting holes here, and those mounting holes are tapped out to M8. This is the angle bracket that piece will be mounted to, and that's drilled out, and I'm using countersunk screws, so that side is also countersunk. The bracket will go on like that, and 2 screws to hold it in, and that's very nice. I'm now making the hinge bolt, so I'm turning this down to 6mm. I use the post to make sure that I have a nice fit. A little bit of knurling on the head, and then I cut a M6 thread in here. Once done, I part that off in the lathe. The thread is a little bit long, so I part the thread off in the vise with the grinder. So it all fits together like this. Nut goes on there, and then it works quite nicely. I have the device in the tool post on the woodworking lathe. Here I'm just leveling off the device, and then I mark it with a center punch on where that hole needs to be drilled. Also go through with a few different angles here. They're center punched as well. This is the results here. The little teeny tiny holes, they're the center punch, but they're so close together I can't put any bigger holes in there. I might have to redesign this part here. So I think in the meantime, I'm just going to have it fixed at level, and then I'll work out how I'm going to be able to tilt it and lock it in place when it's tilted. The last step is to work out where the drill is going to go and make the bracket for the drill. I measure up the collar on the drill here, and we end up with 38.15mm. Now when we're making projects at our wood turning club, one of the more experienced turners there always says draw up a plan of what you're going to do. So here you go, Dick. Here's the plan for what I'm going to do for this part. I cut off a piece of steel to the right size. This is another donation from one of the wood turners. Thank you, Tennis. That piece is milled square and to the right dimensions. Then I drill and tap 4 holes into this piece. Now the 2 holes that I'm tapping here need to be tapped really deep because I need to cut this in half, and I need these tapped holes to go past the halfway line so that I can tap the rest of the hole later on. These 2 holes here hold both sides of the clamp together, and these are the really deep holes that I've gone past halfway. The holes in the back will hold part of the clamp onto the housing of the rig. The next step is to now drill a hole in here at 38mm in diameter. I'm using a center finder and the DRO half function to find the center of this piece of plate. When that spindle kicks out, that means we're right on the edge. Now my white lines are probably going to disappear with all the oil I use, so I'm just making little marks there on its sides, and I'll use those to mark my cut in half line later. Then I start drilling out the hole, and once I get into the bigger drill bits here, I'm going 2mm larger on each one. Yes, this is a 38mm drill bit. I take a measurement, and as per usual, the drill bit drills a little bit bigger than 38mm, which is fractionally bigger than the size we wanted, which is perfect. I redraw that line over those two marks, and then we cut that piece in half. Now I have to go back and tap out right to the bottom of these holes here. Then I test fit the bracket on the drill, and this is really strong. This is not going to move. The last step is to drill the mounting holes for the bracket, and here I've set the DRO into two modes, so we've got absolute and incremental. So the absolute is what I just drilled there. Now I'm moving down to the incremental, and I've got my positions down this end. So these holes can be all done in one setup. The jig is reassembled and the drill is put into the jig, and this is solid as a rock. Very happy with that. Now I'm in the woodworking shop, and I've got the device in the banjo and testing it out for the first time. I do apologise for the wobbly camera. There's a bit of vibration on the wooden floor there. Now you'll see some smoke coming out. This wood is really hard. I started to take smaller bites with the Forstner bit. My lathe has a 24 point index, so I'm rotating this around 3 points at a time, which should give me 8 evenly spaced holes. There is the finished product, and it looks pretty good. I'm really happy with that. So basically from here I would make some different coloured wood plugs, which will be glued into this piece of wood, and then that will be turned into, maybe a box or some sort of cup or something, and the contrast of those different coloured woods would stand out quite nicely. The tool's pretty much finished. I'm going to strip it down, paint up the parts that need painting. I'm going to blue the steel parts that I can blue, and I'll get it all back together. I'll do all that off camera and come back and we'll finish up. Well, there she is, all finished. I've painted some of the parts and I've blued some of the other parts. Off camera, I made these stops, one at the back and one at the front, and they just stop on that centerpiece there, like that. There's some locking nuts, they're all adjustable. I can't get over how firm and solid this is with this bracket holding on the drill. There is another hole in the drill down below, and I thought I was going to have to make a little bracket for that to bolt through onto the drill as well, but obviously that's not required. Here's a front view of the rig, and this is the post and hinge. So that's the pivot bolt there, and there's the locking bolt above it. Now I have this locked in horizontal position, and I'll probably have to revisit if I need to have this tool drilling on an angle, and how I'll actually do that and lock it in specific places. I'm going to make another video of using this on a project and doing a bit of wood turning on the part that I drill out and put inserts into. So that will be a little bit later on, once I've had a bit of a play around with the drilling rig. But for now, that's pretty much the end of this video. So once again, thanks for watching.